Okay. So before I start taking some questions today, maybe we should talk for a minute about what's actually left in this course. There's not a lot of time left. So we have all of next week, correct? Monday, Wednesday, Friday. And then the next week we have Monday, Wednesday, and then we have a final exam. So that's all the time we have. And officially there is a third exam before the final exam in this course. So my plan right now is I would like to give that next week. Okay, so, and what that exam is going to cover is everything up through probably today, but not what's due on Monday. So Monday, there's an assignment due over Taylor series. I won't plan on putting Taylor series on the exam. I'll put Taylor series on the final exam. But the stuff that's due today could be on that third exam. So the third exam will be the Wednesday, Friday of next week. And then, so we'll have a day today of covering 11.2. Monday, we'll do 11.3 and review for the third exam. Wednesday and Friday will be the third exam. And then we're just left with 2 more days where there are 2 more sections we need to cover over like polar coordinates and calculus and polar coordinates. And then we're done. So that's everything. And then we'll have our final. I think I'm a little bit open to suggestions about the final. We have to have it, and I'm assuming they'll probably give us some time for it. What I'm thinking right now is that it will be, I'll send it out to you and you'll have like 2 hours to complete it. I want you to be able to write by hand. I don't like multiple choice math exams. It feels like dirty in some way to me to have you just say, I think it's A. It just doesn't feel good. So what I want is I actually want to do a written exam. The challenge for me also is that it's very, very difficult to kind of say, well, you can't have any notes on an exam that it's not in class. So I'm going to assume for the final that it will be like open book, open notes, and we'll proceed that way. But I think how I'll deal with that is I'll have an actual time limit on the exam. So I'm assuming that they will assign us, and maybe they already have assigned us like a final exam time, and we'll have our final in that final exam time. I'll upload the final exam at the beginning of the final exam time, and you'll probably have like 2 hours or something to complete the final and then upload it, okay? So that's kind of what I'm planning for the final. I'll, of course, announce in the next 2 weeks exactly when that will be. But that's kind of how I plan on doing the final exam. Any questions? Okay. And so now that should give you pretty much a good outline of what is left in the course. So any questions on power series? Yes, sir.
Can we do 22?
22? Sure. Okay. So they want determine the radius and interval of convergence of the following power series. So 22. We have x minus x cubed divided by 4 plus x to the 5th over 9 minus x to the 7th over 16 plus. Okay. So the first thing we could do is we could write this as a closed form. And by the way, x is over 1 if we really want to remind ourselves. And so we could write this as a sum. Let's see, k going from 1 to infinity of x every time goes up by a power, well, we add 2 every time, right? So how could I write what x is doing? it definitely switches signs every time, right? So I get -1 to the what power? Yeah, k plus 1 is perfect, right? Because the first one needs to be positive. So the first one's positive, the second one's negative, the third one's positive, and so on. And then I get x, and what's x's power? The first one is 1. When I plug in 2, I need to get 3. When I plug in 3, I need to get 5. When I plug in 4, I need to get 7. So what is the power of x? Anybody? How about 2k minus 1? Let's see what happens. If I plug in 1, I get 2 minus 1, which is 1. If I plug in 2, I get 4 minus 1, which is 3. If I plug in 3, I get 6 minus 1, which is 5, and everything works. And then what goes on bottom? K squared. Perfect. Okay, so now that we've written this thing in some sort of a closed form, what do we need to try? What should we do now? We're trying to find an interval and a radius of convergence. So theoretically, this converges somewhere, right? For some values of x, this converges. For some values of x, it doesn't converge. And what's really interesting about this is this always converges if you watch the lecture, right? There's 3 ways that this can converge. Either it's at one point, or it's on an interval, or it's everywhere. Those are the 3 things that can happen. So if you have an interval of convergence that's not 0 or infinity, the way that we figure it out is usually by using like a ratio test or a root test or something like that on the absolute value. So what do you suggest? Ratio test, root test? What feels helpful? Root test? Well, the only thing I don't like about the root test is I have to take the square root of x to the 2k minus 1. I don't know. I'm not in love with it, but I'm not saying you can't do it that way either. Let's try the ratio test and let's see how it goes. So I want to take the limit as k goes to infinity of, I'm taking absolute value here, so I don't have to worry so much about the negatives going back and forth. So on top, I get x to the 2k plus 1 minus 1 over k plus 1 quantity squared divided by the kth term, which is x to the 2k minus 1 over k squared. Okay, let's flip and multiply, and I get the limit as k goes to infinity of, on top, we still have, let's see, I guess I could simplify this a little bit. What would it be? It would be 2k plus 2 minus 1. So 2k plus 1. So this is x to the 2k plus 1. Remember, this is still in absolute values. Over k plus 1 squared. Then on bottom, I flip and multiply. I get times k squared divided by x to the 2k minus 1. All right, this is equal to the limit, as k goes to infinity, of, let's cancel some things. How many x's can cancel? Or what's left over when I cancel the x's? X squared on the top, correct? Because there are 2 more x's on top than there are on the bottom. So if I cancel these, bottom and top, I'm just left with x squared. In other words, take this one and subtract this one, right? And I would get 2. So I have the absolute value on top, I have x squared, and then I have this k squared over, I'm just gonna put this over 1 for now. And then I'm gonna say there's also k squared over k plus 1 squared. Now, this has nothing to do with k. So I can just leave it alone. This does, but what's the limit as k goes to infinity of k squared over k plus 1 squared? 1, right? And so we'll just be left with the absolute value of x squared. Now, what test am I using? Ratio test. When does something converge by the ratio test? If this guy is less than 1. Agreed? Now, that's when it converges absolutely. That doesn't mean there aren't other values of x where this thing could converge, but this is where it converges absolutely. Now, when is the absolute value of x squared less than 1? What values of x could I plug in and this be true? What's that?
Anything less than 1.
Anything less than 1?
For values of x.
How about negative 2?
Between negative 1, right?
Yeah, between negative 1 and 1. Do you agree? Because negative 2 is not going to get the job done because negative 2 squared is 4. And the absolute value of 4, of course, is 4. So anything, so negative 1 needs to be less than x, needs to be less than 1. And this thing will converge absolutely. That's not quite enough. We also could say there's 2 other places where this thing could converge, and that's at -1 or 1. If x is -1, it could converge conditionally. And if x is 1, it could converge conditionally. So we need to test those 2 endpoints for convergence. By the way, right now we can say what the radius of convergence is. And what is it? 1. Yeah, that's basically how far is it from the middle of the interval to the edge, or half of the interval. 1 is another way of looking at it. What it really is it's saying the center of this power series, it's centered at 0. This isn't like x minus 2. This is just x. So it's centered at 0, and it's saying how far is it from its center out to the edges of the interval? And the answer is 1. So the radius of convergence, I'll just write it up here. Radius of convergence is equal to 1. Okay, so we're done with that part. Now we need to know for our interval of convergence, is this all, or could 1 or -1 work? So we just literally plug in 1 or -1 for x and see what comes out. So let's say that x equals 1. If that's the case, I just go back here and plug in 1 for x. By the way, what's 1 to any power? 1. So this just becomes 1. So I just get the sum, k going from 1 to infinity, of -1 to the k plus 1 divided by k squared. And the question is, does this guy converge or does this guy diverge? For many, many reasons, this thing converges. First of all, if I look at the absolute value of this, that converges. Because if I had sum of 1 over k squared, that converges, correct? But if it's negative, then I would just have to say, okay, so we just need to do an alternating series test. And does 1 over k squared go to 0? And it does. So, but for many reasons, this converges. So as I'm building up my interval of convergence, this was certainly true. Anything between -1 and 1 converges. But now I found out and 1 converges. So I'll just stick that one on. And then I need to know, what about if x is equal to -1? So let's plug in -1 over here, and I'd get the sum, k going from 1 to infinity, of -1 to the k plus 1, -1 to the k plus 1, and then I'd have times -1 to the 2k minus 1, 2k minus 1, all over k squared. So the question is, how many -1s do we have? This is sum, k going from 1 to infinity, and I get -1 to the k plus 1 times -1 to the 2k minus 1, I add them, correct? So if I add k plus 1 to 2k minus 1, I get how many -1s? 3k, period? Does everybody agree? 3k of them. All right, and then that's over k squared. So if k is 1, what do I get here? -1 cubed, which is -1. If k is 2, I get -1 to the 6th, right? If k is 3, I get -1 to the 9th, which is negative. So it still is going negative, positive, negative, positive, negative, positive, which is the same thing that this was doing, actually, but maybe in a slightly different order, correct? The first one here is negative. The first one here was positive. But for the exact same reasons, this converges. Because it's just alternating, and 1 over k squared goes to 0. So this guy actually works as well. So now here is my interval of convergence. Everything between -1 and 1, and -1 and 1, all will converge. So the idea here, and this happens every time you do one of these problems, is you want to look for the interval on which it mostly converges, which is like between -1 and 1, and then you test the ends to see if the ends converge conditionally. The ends don't converge absolutely. The ends converge conditionally. And then everything else diverges. Okay. Other questions? Yeah.
We do 35.
35. You asked this one, right?
Yeah.
Did that answer your question?
That was great.
Okay. 35? Is that what you said?
Mhm.
Okay. 35. So we have, let's see, combining power series, use the geometric series, okay. To find a power series representation for the following functions, give the interval of convergence of the new series. Okay. Let me write this down. Did you say 35? Oh yeah, I was reading 45. That's not good. I found that like I'm slightly losing my mind. Not really, but like the last week, 2 times. Okay, so I'll tell you my quick story. I just think of myself, I have a pretty good memory. Okay, and I don't lock my keys in my car. You know, I don't like forget my wallet places. These are things that don't happen to me very often. Some people they happen more to, and that's not a good or a bad thing. I just happen to have a fairly good memory. In the last week, 2 times, I've walked out of a store and just left something. Like, and one time it was like an item that I paid like $150 for, and I left it in the store, and I got all the way home, and it was like a half an hour away, and I was looking through all the stuff because it wasn't just that I bought. That would be really bad. But I looked through all my stuff, and I was like, "Where's that item?" And I'm like, I couldn't have just like left it in the store. And then I did. I had left it in the store and I had to go get it. And then it happened again, like in the same week that I like left a whole bag of stuff in the store. And I was like, am I going absolutely insane? So hopefully not, but it's been, my wife said, now you get to know what everybody else feels like all the time. And I was like, well, whatever. Okay, so 35. Or was that right?
Yeah.
Yeah, 35. Yeah, the pen. This one's better. Okay, so we have the sum. K going from 0 to infinity of k to the 20th times x to the k divided by 2k plus 1 quantity factorial. All right, so, and what we want to do is just, again, find the radius of convergence and the interval of convergence. Right off the bat, I see that we have a factorial, and that kind of screams to me ratio test, not root test. So we'll use the ratio test. So I want to look at is the limit. K goes to infinity, the absolute value. Now I want to plug in k plus 1s on top. So I get k plus 1 to the 20th times x to the k plus 1 divided by 2 times k plus 1 quantity factorial divided by k to the 20th times x to the k over 2k plus 1 quantity factorial. Those my absolute value. Okay, so this is the thing that we need to find the limit of as k goes to infinity. Obviously, we can simplify a little bit and flip and multiply. So let's do that. So I get the limit as k goes to infinity of, on top, I still have k plus 1 to the 20th, x to the k plus 1. On bottom, I have, this is k, 2k plus 2 plus 1. So that's 2k plus 3, 2k plus 3, quantity factorial, times, flip and multiply, I have 2k plus 1 factorial, divided by k to the 20th, times x to the k. All right, so some things cancel. First of all, I have kx's on the bottom and I have k plus 1x's on the top. So all but one of them goes away and I just have an x on top. Not a lot I can do here, but it's going to be okay, I think. I can cancel, this is 2k plus 3 times 2k plus 2 times 2k plus 1 factorial is what 2k plus 3 factorial could be written this way. So I can cancel the 2k plus 1 factorial, and all that's left is 2k plus 3 times 2k plus 2. All right. So when I take the limit, the x does nothing. It has no k's involved. So I just get an absolute value of x. And then I have the limit as k goes to infinity of all the other stuff that's left over, and let's be very careful. On top, all I have is a k plus 1 to the 20th. And on bottom, what do I have? I guess I have a 2k plus 3. By the way, this is still an absolute value, times 2k plus 2 times k to the 20th. And that's it. Now, what happens when I let k go to infinity of this mess? Yeah.
Goes to 0.
And why 0?
Because there's a higher power of k on the bottom.
Right, yeah.
You can have a k to the 22 on the bottom.
Yep.
Only a k to the 20 on top.
That's right. So the power of k on the bottom is higher than the power of k on the top. So we know that that goes to 0, right? We could do like 20 L'Hopital's rules if we wanted to too, but we don't want to. Okay, so the power is greater on the bottom, so this thing goes to 0. So I just get absolute value of x times 0, which just happens to be 0. And 0 is definitely less than 1. For all x's, right? I didn't say just certain x's it was 0. Every single value of x would give me 0 by the ratio test, which is less than 1. So we can conclude what?
It converges.
Converges everywhere. And so what's my radius of convergence? Infinity. That's right. So my interval of convergence is from minus infinity to infinity. And my radius of convergence is infinity. So it converges everywhere. Cool. Other questions? Yeah.
31.
31. All right, I have k going from 1 to infinity of x to the 2k plus 1 over 3 to the k minus 1. X to the 2k plus 1, 3 to the k minus 1. So we have some k going from 1 to infinity of x to the 2k minus 1, 3 to the k plus 1, or was it minus 1?
Minus 1.
Minus 1. Not that it matters that much. Minus 1.
And the top is plus 1.
Oh, it is plus 1. Okay. So 2k plus 1 on top, 3k minus 1 on bottom. All right. It looks like another great place to use a ratio test. I don't see any real compelling reason to use a root test. So ratio test it is. Let's look at the limit as k goes to infinity of the absolute value. On top, I get x to the 2 times k plus 1 over 3 to the k plus 1 minus 1 divided by x to the 2k plus 1 divided by 3k minus 1. Okay, we can flip and multiply. This is the limit. K goes to infinity of, on top, let's simplify this a little bit. This is x to the 2k plus 2 plus 1. So it's 2k plus 3. So I get x to the 2k plus 3 divided by, on bottom I have k plus 1 minus 1. So it's just 3 to the k. 3 to the k times, now I flip and multiply this guy, I get 3k minus 1 on top. And on bottom, I have x to the 2k plus 1. X to the 2k plus 1. Okay, now we can cancel some stuff. What's left over after everything happens? How many x's will I have? Yeah, an x squared on top, right? I can subtract if I want to. And this will give me x squared. And then how many 3's will I have? Yeah, 1, but it will be on the bottom. So all but one of these goes away. So when I'm done, I get the limit. K goes to infinity of x, absolute value of x squared is on top, and just a 3 is on the bottom. But where have all my k's gone? They don't exist. That's just a constant, right? And the limit of a constant is just that constant. So I just get the absolute value of x squared over 3. And in order for this thing to converge absolutely, that needs to be less than 1. For an absolute value to be less than 1, that means that the thing inside lives between -1 and 1. Right? So if I multiply all sides by 3, I get -3 is less than x squared is less than 3. So if x squared, which is certainly a positive number, is between -3 and 3, so it really is, x squared is between 0 and 3. So where's x?
Zero and square root of 3.
Close. That's certainly true. Yeah, negative
Absolute value is three.
-√3. Because would you agree that if I plugged in something like something smaller than -√3, like -1, let's say, up here, would it be true that -1 squared is 1 over 3 is a third? Is the absolute value of a third less than 1? Yeah, so things in here all work. Okay, so we're close here. But this does tell us our radius of convergence. And what's the radius of convergence?
Root 3.
Yeah, square root of 3. So our radius is equal to the square root of 3. And now we need to know the interval, and we're close. We just need to know, is that an equals or is that an equals? So we need to go back to the original and plug in the square root of 3 and negative square root of 3 and see what happens. Or x. So first let's let x be equal to the square root of 3. If we do, then I get the sum, k going from 1 to infinity, of the square root of 3 raised to the power 2k plus 1 all over 3 to the k minus 1. This is interesting because we've got square root of 3 and we've got 3. I could change these to square root 3's by saying it's the square root of 3 squared. Correct? So I could write this as the sum, k going from 1 to infinity, of this is the square root of 3 to the 2k plus 1 divided by, this is the square root of 3 squared, then raised to the k plus 1. I'm sorry, the k minus 1. So how, if I raise something that's raised to a power, what do I do with those numbers? Multiply them, that's right. So if I multiply those, I get sum k going from 1 to infinity of square root of 3 to the 2k plus 1 divided by the square root of 3 to the, if I multiply these, I get 2k minus 2, 2k minus 2. Okay, which is, what happens, what's left over in this? This is very interesting, by the way. So what do I get? So I subtract this from this. So how many more square roots of 3 are there on top than on the bottom? 3 of them. So this is the sum, k going from 1 to infinity, of the square root of 3 quantity cubed. Now, what is this? Okay, square root of 3 quantity cubed, it's like 3 root 3, right? But what do I do if k is 1? What do I add? Not nothing. 3 root 3. What do I add if k is 2? 3 root 3. What do I add if k is 3? 3 root 3, and so on. So I add up infinitely many 3 root 3s. What do you think it will be? Infinity. Right, so basically what we're saying here is if I add up any number other than 0 infinitely many times, I get infinity or negative infinity. So this is certainly infinity, and that does not converge. So I'm not going to be adding this guy. That doesn't work. So now we need to test the other one. What if x is equal to negative root 3? So plug that in up here, and I get the sum, k going from 1 to infinity, of negative square root 3 raised to the power 2k plus 1 divided by 3 to the k minus 1. All right, well, I could split this up a little bit into the negative 1 part and to the square root of 3 part, correct? So I could write this as the sum. This is negative 1 to the 2k plus 1 times root 3 to the 2k plus 1 divided by 3 to the k minus 1, k going from 1 to infinity. So this is exactly the same as the last one, except at the end here, I'm going to have a negative 1 to the 2k plus 1 sitting there. So let's see what happens. So I'd have sum k going from 1 to infinity of negative 1 to the 2k plus 1, and then I'm going to have times square root of 3 to the third. So what happens here? What if k is 1? So this is odd, so I get negative root 3 to the third. What if k is 2? What do I add? So if k is 2, I get 2 times 2 is 4, plus 1 is 5. Negative 1 to the fifth is negative. By the way, what will this number always be? It's always odd. So this is always a negative 1. So I might as well just say, it's negative 1. So this is just adding up the same thing over and over, just negative. So that's negative infinity. That doesn't converge either. So neither of the sides end up converging. And so this is just my interval of convergence. It's just from minus root 3 to root 3, no endpoints. Other questions?
Did you do 28?
28. Let me take a look. 28. Okay, I've got k going from 2 to infinity of x plus 3 to the k over k times ln squared of k. All right. 28. Sorry about the pen situation here. I don't know if I have an extra one or not. Guess I'll have to make do. Okay, so we have 28. We have the sum of k going from 2 to infinity of x plus 3 to the k divided by k times ln squared of k. K times ln squared of k. All right, and I think I want to just proceed as we have before. Let's just use a ratio test. There's some argument here that, hey, you could use a root test. And it's true, I probably could. I still don't know that, like, I'm totally in love with a kth root of ln squared of k. It's fine, maybe we could deal with it, but I'd rather not if I don't have to. So let's just use a ratio test. So this is limit as k goes to infinity. Put in the k plus first term on top. So I get x plus 3 to the k plus 1. This is all absolute value over k plus 1 times ln squared of k plus 1 divided by, then we put the kth term in, x plus 3 to the k over k ln squared k. Now we can flip and multiply. We get the limit as k goes to infinity of x plus 3 to the k plus 1 divided by k plus 1 times ln squared of k plus 1 times k times ln squared of k divided by x plus 3 to the k. Some things cancel here. All but one of the x plus 3's cancel. And then I have some other stuff, right? I have some ln stuff hanging out. What would you suggest? Well, let's see what's left and see how bad it is. So let's rewrite. This is limit as k goes to infinity. The x plus 3 doesn't have any k's involved anymore. So I just get like an absolute value of x plus 3 sitting here. And then all the other stuff is the absolute value of k ln squared of k divided by k plus 1 ln squared of k plus 1. Well, first of all, I see a couple things that we could kind of mess with. I have k over k plus 1. And the limit as k goes to infinity of k over k plus 1 is just 1. So if we could take the limit as k goes to infinity of ln squared of k over ln squared of k plus 1, then we'd sort of be done. Yeah.
You put the ln squared because like of its addition, so if you put times it, like ln squared of k times ln squared of 1.
Okay, so you're saying write this as ln of k times ln of k?
Or on the bottom, like ln squared, because like, isn't it like when you multiply ln or natural log, so you have to add them when you're dividing them? And then when you minus them, it's like dividing.
So
Or
if you add them
okay,
externally, if you
okay.
add them,
Yeah,
then they're multiplied when you combine them.
yeah.
And if you subtract them, then they're divided when you combine them. But here, we're multiplying an ln times an ln,
Mhm.
which is neither of them. works.
Yeah.
So we can't do that, unfortunately. But what I can do is I can say, okay, this is absolute x plus 3 times the limit is k goes to infinity of k over k plus 1 times the limit is k goes to infinity of ln squared k divided by ln squared k plus 1. And now if I plug in, this is 1. This is still a mess, but it is definitely infinity over infinity. So I could use L'Hopital's rule. And maybe that would help me out. So let's see. If I did use L'Hopital's rule, I still have this absolute x plus 3 hanging out. This one I said was 1. This one, I need to take the derivative of the top and of the bottom. So I have ln of k squared, the derivative of that, I have limit, k goes to infinity, of 2 times ln k times the derivative of ln of k, which is 1 over k, over, same thing on bottom, I get 2 times ln of k plus 1 times the derivative of k plus 1, which is, I'm sorry, the derivative of ln of k plus 1, which is 1 over k plus 1. Everybody with me? So I just did the chain rule. This is equal to, well, the 2's cancel, and I still have absolute x plus 3 times, now, this k goes on the bottom, this k plus 1 goes on the top, if I were to put them in their correct positions. So this is limit, k goes to infinity. The k is on the bottom, the k plus 1 is on top, so I have absolute k plus 1's on top, the k is on bottom, times on top I have an ln of k, and on bottom I have ln of k plus 1. But again, the limit as k goes to infinity of k plus 1 over k is 1. So this one's kind of gone, and I just need to do this one. So I still have absolute x plus 3. And now I could use L'Hopital's rule. So I have limit as k goes to infinity of derivative of ln of k is 1 over k. The derivative of ln of k plus 1 is 1 over k plus 1. And what is that limit? Of course, this is k plus 1 over k, which is 1. So I just end up with absolute value of x plus 3, and that needs to be less than 1. Okay, when will that happen? That's when -1 is less than x plus 3 is less than 1. Subtract 3 from all sides, and I get -4 is less than x is less than -2. So what's the radius of convergence?
2. No.
1. That's right, 1. And the way that you can know is the center of this thing, since there's an x plus 3, is the thing that I'd plug in for x to get 0 here. So it's at -3. So the center of this power series is -3, and it should be equal on both sides of -3. And it is. How far away is it? 1. So the radius of convergence here, sorry about this pen, it's horrible, is equal to 1. And then the interval is between -4 and 2. We're not done yet, right? We need to run the 2 other sides to see if they converge conditionally, but I will let you do that on your own. You've seen me do it 2 other times. You still need to test -2 and -4, but we have almost everything. Okay? Very good. Thank you, everybody. Have a good weekend. And next week, we will start the final countdown with classes till the end of the semester. Have a good day. Thank you. Yeah.